So the code runs and it looks fine. If you take a close look, then you can see here there's a couple spikes at the end for joint velocities, which doesn't make quite sense. These come from the Tepee being in a singularity position at its start when the legs are both folded up together and pointed in the same direction. So at that point, the Jacobian equals 0, and so the joint velocities are undefined. Now, the position looks fine, and the animation ran smoothly. So if we look over in the command window, though, we can see there are a bunch of warnings that printed out. So this video is going to cover how to fix warnings, and then also how to define a custom color and fill in a patch in order to make the TP look like an actual brown TP. So there are two ways that Matlab shows errors. One is in the command window. If it's an important error, it will print out here. Errors are in red and warnings are in orange. So if it's an error, the code will not continue to run past the line that had the error. If it is a warning, the code will still run, but there are problems that you may want to fix. The other way that Matlab shows warnings or errors is over here on the right side of the editor window. You can see it's orange, which means warnings are found. If that square were red, it would mean that errors were found, and if the square is green, then it means that your code should run fine, no problem. So let's go through and start with this first warning here. This says matrix is close to singular or badly scaled. Results may be inaccurate. So that singularity happens. Okay, that is here, theta double dot equals inverse J times B. So we can see here that the INV is underlined, and it basically, INV parentheses J is just taking the inverse of J, the Jacobian matrix. But there's another way to do it, A backslash B, which would just be, in this case, J backslash. So both ways work, but because this starts at a singular configuration, it's recommending that we use J backslash, just like we did for velocity. So we'll get rid of that. Now, the second error is here. It says, warning, error updating legend, all of this stuff. So let's click on that line. And we can see here that the equal sign is underlined. We highlight that, it says terminate statement with semicolon to suppress output within a script. So we need to fix that. Let's just put a semicolon at the end of this line. And same thing down here on the acceleration. And same thing here on the position. All right, so now let's run this. First, we'll run this section to clear. So everything goes away, and we'll run the code again to see if anything prints to the command window. Looks like it's running fine, no warning so far. All right, the joint velocity still has a little spike there, but that's expected because of starting at a singular configuration. So now let's look at the errors that are in this right sidebar. So the first one, the variable R1D appears to change size on every loop iteration. Let's click on that. R1D is underlined, and we can see this is because we have not pre-allocated arrays for these variables. So the way that Matlab works, actually, let's do this on the whiteboard. So the way that Matlab works with array pre-allocation or not array pre-allocation, which is the warning that we're getting, basically, whenever a variable changes size, Matlab creates a whole new variable for it. So in the code, we had R1D, which represents the linear velocity of R1, the base of the TP. Now, when we first run through the for loop for that calculation, R1D is some value. So we'll just make an empty box for it. This is when count equals 1. Now when count equals 2, it adds another variable to R1D. So now R1D has 2 spaces. But instead of just adding a space on, Matlab will create a whole new variable with 2 spaces. So now you've used up the first time, total 1 space is used up, and the second time, 1 plus 2, so now 3 used up. Now for count equals 3, R1D will have another thing added onto it. So now it takes up 3 spaces, but what Matlab does is it's going to create another variable, and so it won't be able to use those old R1Ds. Now it will have a new one. And so now we'll get a total of 6 spaces, 3 from the before, and then the 3 new ones. So you can see how this is going to create way too many spaces than necessary. And what's going to happen is eventually Matlab can run out of memory. So to pre-allocate arrays, we just figure out how many spaces does that variable or array need to have, and just make an empty vector for it at the beginning that we'll be able to fill in the spots of. So going back to Matlab, R1 we know is going to have as many spaces until count equals n. So it will have n spaces. So let's go up here and pre-allocate arrays for it. So R1D equals zeros. We'll just fill an empty vector of zeros of n rows, 1 column. So this will make a column vector. If we wanted to make a row vector, we would just have zeros of 1 row, comma, n columns. So it would be the opposite shape. And then T3D equals zeros and 1. So that is 3 velocity. You can see 2 of 6 little orange bars went away. And let's check on acceleration. Yes, those are both underlined. So like it says, pre-allocate for speed, we will go and make acceleration pre-allocations. R1 double dot equals zeros and 1. All right, so now we're down to 2 warning bars. So let's see. If you need to specify expression precedence, use parentheses instead of brackets. So let's see what is the issue here. Okay, so that is down here. You can see these brackets are underlined. So we have, this is the BA matrix for acceleration. And we define the first element, and then we define the second element, and then we put them together into BA. So really, we don't need brackets around BA1 and BA2 because there's only one thing there. It's just this expression, and then we'll put them together into a matrix where we use the square brackets on line 48. So let's just take away, because BA1 and BA2 are scalars, and we can verify that here. BA1 is a scalar, BA2 is a scalar, and BA, we'll double click that, should be a 2x1 column vector with 2 numbers in it. Good. Okay, so now it's green. Matlab is all happy. No warnings are found. So let's and see what happens. So we've got our Tepee opening up, running smoothly. Next thing we need to do is make it brown so it looks like a Tepee. Oh no, we have a problem. And this one's an error because it's red. Error using plot, vectors must be the same length. So let's check on line 109. What's not the same length? T2 and velocity. So you can see here for the velocity matrix, we have defined R1 dot and T3 dot are the and we have transposed them, which is putting the apostrophe at the end means flip rows and columns. So the reason that we got this error, if we go and look at velocity, velocity here is a 1 by 180 double. We'll double click on that and look at it. you can see that is a row vector. And it is 180 columns and 1 row, which doesn't quite make sense because T2 is a 90 by 1. We'll double click on that. Okay, so T2 is a 90 by 1 column. So what happened when we transposed these, originally we had made our arrays pre-allocate into columns, whereas before they had not pre-allocated. And so if you don't pre-allocate, it automatically goes into row vectors. So we needed to transpose them. We pre-allocated for columns. No, now we don't need these transposes. So now we'll take away these apostrophes. And same thing on acceleration. And so now instead of a 1 by 180, we should end up with 90 by 2, because these are going to be side by side instead of front to back. So let's clear that and then run this plot section and see what happens. All right, so now we got the velocities and accelerations, and if we just double check over here, velocity is a 2 column now, so that is good. Okay, so the next thing that we need to do is make the brown. So the next thing that we need to do is make this TP brown so it looks like a real TP. We can define a custom color for that, and we'll use the patch command to fill in the triangle for the plot. So first, let's define our custom color, because brown is not a built-in color to Matlab, so we need to actually define an RGB matrix for it. So let's go and look up what is RGB for brown. Okay, shades of brown. Let's do TP. Okay, buff looks a lot TP color. Some dried deer or something. So that the RGB is 280, 160, and 9. And these are based on a 0 to 255 scale. Now, Matlab scales theirs from 0 to 1. So that means we'll have to divide all these numbers by 255 to get them within the right scale. So we have 218, 160, 109. Let's go define our custom color in Matlab. So down here, we'll say define custom color. And that is buff equals 218, 160, 109, and then we'll divide by 255. Okay, so we've got the custom color, and now we're going to use it in a patch. So down here, in order to fill in that triangle, we use the patch command. It works very similarly to a plot, where you put the X coordinates, the Y coordinates, and then the color. So we'll say all X, all Y, and buff. All right, it's green, no warnings. Let's run this and see what happens. Beautiful. That is the color that we wanted.